Let us start. The rest will find us on the way. They'll find us to have started. Okay. Good morning once again. This lesson is brought to you by Yaaka. It's our last free chemistry lesson. It's in year 2. And next week, for you to attend, you'll have subscribed first to Yaaka Digital Network. And then you can take part in these classes and also enjoy our integrated content on our websites and all that. So I hope I'll see you next week when you have all subscribed. Thank you for making it early. Hamira is asking, how do you subscribe? Host, please, you can send out a message in the Senior 2 group on how to subscribe. Amira is here asking. So we'll send out a message in that group and you see the link to follow for you to be able to subscribe. You can pay the amount on our mobile money or on our bank account, or you can use a Visa card or whatever you choose to use. I shall send out a message and you see what I mean. Okay, so today we'll be looking at electrochemical series or reactivity series. Last time we looked at something that led us to this. Who can remind us on what we looked at last time? Who remembers what we looked at last time? Who remembers? What did we look at last time? Oxide. Yes, oxides. That is correct. We looked at oxides, the different types and classes of oxides. So now today we shall look at how different elements react with oxygen or attract oxygen molecules. I have an example here of how some metals react. Okay, some metals react explosively, meaning there is a lot of heat produced. Okay, some react vigorously, meaning there is a lot of activity during the reaction. Others react slowly, and that's what we are looking at when we say the reactivity series. We're just concentrating on how different metals react. Today we shall see how they react in relation to oxygen, or reacting with oxygen. Okay. So reactivity series is just the arrangement of elements in the order of their readiness to react with each substance or with other substances. The most reactive elements are placed at the top of the series, and the least reactive elements are placed at the bottom. So that's how it goes. We shall see it towards the end, how we arrange these particular elements according to their reactivity. Okay. We shall first concentrate on metal competition for oxygen. Okay, metal competition for oxygen. Who can tell me what this means? Metal competition for oxygen. I even have an equation here showing it, how it happens. What does it mean when someone says metal competition for oxygen? What is happening here? Is there anyone who can interpret that for us? Metal competition for oxygen. So here we're looking at how metals can displace oxygen from one another. For example, in this equation, we're seeing that magnesium is displacing the copper from the oxygen. So therefore, it is taking up the oxygen. The magnesium atom is taking up the oxygen, and the copper is remaining alone. Why is this able to happen? What characteristic does magnesium have over copper? Yes, okay.
Because magnesium is higher in the reactivity series than copper.
Okay, so if it is higher, what does that mean? Is it more reactive or less reactive?
It's high reactive.
Okay, very good. So magnesium is more reactive than copper. This is why it is able to displace the copper from the oxygen atom so that it can take it up by itself. All right, so that's an example on how reactivity series work in real time. Okay. So metals which are higher in the reactivity series are more reactive metals and tend to remove oxygen from the oxides of metals that are lower in the reactivity series or less reactive metals. For example, this equation. So that's exactly what Okello said. Okay. So that's how these reactivity series work. The metal that is more reactive can displace the other that is less reactive from an oxygen atom. Okay. Any questions so far? Is there something you don't understand that I can repeat, explaining, or if you have a question? This here is an example of a metal reacting with oxygen. It is normally potassium or sodium that reacts like this when you expose it to air, then you kind of put some heat on it or put some water on it to react explosively like that. In this case, magnesium is more reactive than copper, therefore moves the oxygen from it. This is exactly what we have said. Comparing reactivity of metals. Okay. So let's start with potassium and sodium. When potassium and sodium are freshly cut, okay, remember these are soft metals. So when say freshly cut, don't be surprised. Group 1 metals are very soft. You can cut them with a knife, okay? So when they are freshly cut, they are silvery and shiny. They're very, very shiny metals. But their surfaces rapidly tarnish, meaning they lose that shininess in air because they quickly react with oxygen in the atmosphere to form oxides. Potassium tarnishes more rapidly than sodium, indicating that it's more reactive than sodium. So when you look at this picture here, in this picture, I'm trying to show you what exactly happens. Okay, so we have, this is sodium that has been cut. Okay, sodium is mainly silvery, like silver, gray. It is in a gray color and very shiny. But as you can see here, it has lost its shininess. It is now coated with a tarnished coating, meaning the surface of it has reacted with oxygen, and therefore it forms an oxide on top, which oxide is not that shiny like the metal. Okay, so that's what happens. That's what happens to these two metals. Sodium and potassium react the same way. It's just that potassium is more reactive. That's the difference. That's the difference. Any questions here? Question? Okay. We can continue. Let's look at another metal. Magnesium, how magnesium reacts. When a piece of magnesium is polished, tiny, silvery surface is exposed, the surface remains shiny for some time before turning gray due to the slow reaction of magnesium with air, forming magnesium oxide, a gray coating. Magnesium is less reactive than sodium and potassium. Magnesium also reacts with air, but it is just slow, with oxygen, but it's just slow in its reaction. I have an example here. This one involves a little bit of burning magnesium, but it will take us to the point. So when magnesium is not yet is new, it is not yet exposed to air, it is very shiny, okay, and well polished. But once it is exposed, it absorbs the oxygen atoms, or it reacts with the oxygen atoms in the air. And then once it reacts with oxygen atoms, it forms this oxide. This oxide is the one that is gray. It turns it. It forms a gray coating around the magnesium metal. Okay, so that's what happens. That's what happens when you expose magnesium to the atmosphere. All right. It forms that gray coating all over the magnesium. That gray coating is the magnesium oxide. Okay. When you burn magnesium in air or in oxygen, it burns with this very, very bright flame, forming white ash, which is magnesium oxide. So when magnesium oxide is entirely formed, it is just white ash, somewhat gray, but mostly white. All right. But when just oxygen is being, magnesium is exposed to air or oxygen, it forms a gray coating around the magnesium metal. Okay, but this formation is a little bit slow. It is slow compared to that of sodium and potassium. Excuse me. So it is a little bit slow. And this tells us that magnesium is less reactive than these two. Okay. That's the point I want you to take here. Any questions so far? Questions? Okay. If there are no questions, we can continue. Please make sure you ask questions when you don't understand. Let's look at aluminium. aluminium and zinc. Okay, aluminium and zinc. What do you think is more reactive between aluminium and zinc? Which one is more reactive? Who knows?
Aluminium.
Okay.
Aluminium.
Okay, good. So these ones are also very, very shiny metals, although their surfaces get coated with thin layers of their respective oxides on exposure to oxygen. Aluminium and zinc react more slowly with oxygen than magnesium, forming their oxides. Hence, aluminium and zinc are less reactive than magnesium. Also, these ones form shiny. They form a coating around their shiny surfaces. An example is right there. This is aluminium, okay? And when you look at aluminium, once it is exposed to the atmosphere, there's a coating that is formed around it. As you can see, it is not as shiny as it should be. Okay, it looks a little bit rusty, but it's not rust. It is just that coating of aluminium oxide that prevents its shininess. Okay, but the reaction is very, very slow. Very, very, very slow. All right, it is very, very, very slow. When you look at the wires, the electric wires around your home, not inside your home, but outside on the poles, those electric wires are made up of aluminium, and they are not shiny at all. Okay, the reason why they are not shiny is because of this coating, the aluminium oxide, which is formed around them. This coating also protects the aluminium somewhat from the weather conditions. Okay, so the inner wire is protected due to that coating that is formed due to the exposure of oxygen to oxygen. So aluminium doesn't get destroyed easily in terms of probably the water vapor destroying its composition or whatever. It doesn't, because the moment it exposed to air, it forms this coating around it so that the water vapor does not penetrate through, or other materials that can destroy it. This is why it is normally used for transmitting electricity. Okay. So that is aluminium. And zinc. Zinc acts the same way. Okay. Also forms a coating, but it's very slow. So aluminium and zinc are less reactive than magnesium. Questions? Any questions here? Okay, very good. We can continue if you guys don't have any questions. Let's look at copper. Copper is a brown solid and does not react with oxygen from the atmosphere, but reacts with carbon dioxide and water from the atmosphere to form a green solid of copper 2 carbonate. Copper is therefore less reactive than aluminium and zinc. From the above reactions, we can establish the reactivity series of metals. Now, when you look at copper, this is a penny right here. It's made up of copper. And I'm trying to highlight this part here. Okay. This is a penny. is made up of copper. When you look at this side is greenish, okay? It's greenish. And this side is still pure. This side is still pure, okay? So this side has been contaminated by carbon dioxide and water, forming a greenish substance called copper carbonate around it, meaning that this side has been exposed to those contaminants. Therefore, it has reacted with it. This side is still pure, okay? It is well cleaned and polished. It is still in the pure color of copper, which is brown, all right? And this should show you the difference on how copper reacts with carbon dioxide and water, okay? It shows you the difference. But the fact is, copper hardly reacts with oxygen. It's very hard for it to react with oxygen. You have to put it under different conditions for it to react with oxygen. But the atmospheric oxygen does not react with it. So you can't leave a copper wire or this penny outside and think that, oh, it's going to react with oxygen or whatever. No, to react with the carbon dioxide and water, but not the oxygen, okay? Who can tell me the use of copper, one of the uses of copper, especially in our homes? Who can tell me? Copper, the uses of copper. Copper. Who knows? Making wires. Okay, well, that is correct. Copper can be used in making wires. It cannot be used as an insulator because it is a conductor. It conducts electricity. Insulators do not conduct electricity. So copper is used in making wires. Most wires you've seen at your home, in your house, in those cables that you connect to your computer or the wires that help charge your phone, most of those are copper wires, okay? It's also used in making some coins, that is correct. Making some coins, we've already seen a penny that is made up of copper. Which Ugandan coin is made up of copper? Which Ugandan coin is made up of copper? The 500 shillings. Yes, Shani, that is correct. The 500 shillings is copper. I believe so. Okay. So that is good. So this shows us how different metals react. These are the common ones that I picked out for us to investigate and see how they react and how they can be arranged in their reactivity series. Okay, those are the ones. Yes, someone has a question. I saw someone's hand up. Was that okay? Someone's hand was up. Any questions? Okay, very good. We can continue if there are no questions. I want to remind you that at 11, you guys have mathematics. I believe so. You guys have Mathematics, yes, at 11 a.m. And we have a session for you at 1 p.m. on how to search the internet effectively. So please make sure you attend those 2 sessions next. So at 11, you have mathematics. Then at 1 p.m., you have a session on how to search the internet effectively. So most of you think you can Google anything and get it. But today you learn how to search the internet. For example, if you were looking for something and probably you want a PDF or you want a PowerPoint or you want any type of document in the work that you're looking for, how to search that, how to do image searches and things like that. For example, you can have this coin here and you want to know what it's made up of. How do you search using this image? Okay, things like that. So attend that class, that session at 1 p.m. You will learn a lot. I'm sure you'll appreciate it. Okay. So now with what we have looked at, we can deduce the reactivity series or the what? How the metals are arranged from most reactive to least reactive. So this is the arrangement here. This is the arrangement. We have potassium being the most reactive, okay. We have sodium, we have calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. And that is the arrangement from most reactive to least reactive. Okay. Now, our activity right now that I want you to work on is finding an acronym. Okay. You guys know acronyms? Do you guys know acronyms? Yes? Let me see if you guys know acronyms. Yes, okay. You guys know acronyms. So acronyms are like a short form of something that is huge. So you can find an acronym for this reactivity series, and I want you to come up with it and then submit it to me, and I see how you've done it. Yeah. I want you to come up with your own. Okay. Yeah, I have mine on how I memorized these reactivity series, but I want you to come up with yours. All right. So can you guys do that for me? Before you go for mathematics, make sure you do it and submit your acronyms. I would love to look at them. Okay. You can even make a song out of it if you want. And then if you have a good voice, you can send a voice note. You can submit via my inbox on WhatsApp or in the group. But if you submit in the group, people will copy. Yet I don't want people to copy your great acronyms. So you can always inbox me those acronyms, and if you make a song out of it, also make sure you send it. And after listening to the song, I'll share it in the group and say, so and so made this song. I hope you won't be embarrassed. Okay. Everyone will listen to your reactivity series song. Okay, so any questions here? These are our reactivity series. I've showed you how we come up with them. We just see how these metals react with other substances, like especially oxygen, but also we have seen the one with copper, how we deduce the one with copper. So that's what we concentrate on. Okello has one here. Please, sir, can Matthew add common Zambia. Ignore ladies. Here comes my sister, Grace. Okay, that's a good one. Keller has already submitted his. So you guys are next. Okay. All right, good job. Good job today. If you don't have any questions, please, if you have questions, ask now, or you can always type them later in the WhatsApp group. Innocent has a question. Yes,
Yes.
Innocent.
My question is, like
Mm.
when you say when substances which react with oxygen,
Mm.
can't you not put them as part of non-transitional cations?
Non-transition what?
Non-transitional cations.
Non-transition cations. Okay. I don't think that would work well, but because when you look at the transition metals versus non-transition metals, it will not make sense for us to relate them like that, because we have copper here, okay, and we all know copper is transition. It's a transition metal, and it is part of these metals that we are looking at, okay? It is part of these metals, even though it doesn't react with oxygen from the atmosphere. But when we start relating between transition and non-transition in these reactivity series, it will ruin the point, because these are mixed, okay? These are mixed. We have transition and non-transition metals amongst these we have looked at today. These are just the most common ones that we wanted to look at. Okay?
Yes.
Because they're mixed. You can see iron here, you can see lead here, copper, gold. Okay? So it's a mixture of transition and non-transition. You get the point?
Yes.
Okay, good. Any other questions? Okay. So I was saying, remember to view our services here, and please encourage your parents to subscribe you to Yaaka Digital Network for us to continue learning throughout. Okay. Like we told you, you can only pay 500,000 for a whole year. Okay. And if you get promoted to the next class during that year, we still also promote you this site so that you can access the content to the class you have moved into. Okay. So you access content on our websites, you access teachers 24/7 days of the week and hours of the day. Okay, there's no resting. You can utilize the website to pace yourself. You can even do work up to, for example, if you're in first term, you can do work up to third term in any amount of time you want in that period of the year. So for example, if you're in term 1 and you want to access work from term 3, you can do that easily, okay? Easily. So it doesn't matter. For us, we just give you the whole year and you can access all content. And the teachers will be available for you. For example, you say, teacher, for me, I don't want to learn about oxides. I want to learn about something else. The teachers will teach you that, okay? We don't follow the conventional way of teacher deciding what the student learns. No, the student can decide also what they want to learn. If you have a problem somewhere, maybe in balancing equations or writing equations, we'll look at that, okay? We just look at that and then we move forward like that. So we teach in accordance to your needs, in relation to your needs. Please send cats and cats, monkeys, and zebras in lovely, happy cages made of silver and gold. Hey, that's another good one. Shani has also made a good one. Okay, so I was saying, make sure you encourage your parents to subscribe you to Yaaka, because this is a really a great opportunity for you to learn easily on your pace. And even when you're at school, when you go back to school, you can still access our websites from via your computer labs and do assignments and do activities and submit. And the teachers always send you feedback via your email and like that. Okay. And when you come back for the holidays, then these engagements via Zoom continue. Okay. So learning doesn't have to stop given any circumstance. Okay. Right now we're in lockdown. Most of you can't access your teachers, but Yaaka will be here to help you out. We have all the qualified teachers you may need. So it is important for you to remember that. Again, I want to encourage you to attend today's session at 1 p.m. Okay. First, attend math at 11 a.m. and then attend the session at 1 p.m. about internet searching. So don't forget to do that activity. I want to see it. Okay. Good job. Rest and then wait for math as you do that activity. See you soon. Bye. For now, you have been studying for free. Galaxy J3 Pro. You've been studying for free, so don't worry about paying for what you've been studying for. This one was a free session. Next week, that's when we shall be requesting you to subscribe, or you should have subscribed by then for you to attend next week. But the last 3 weeks have been free. Okay, good question. Bye-bye.
Okay, maybe to add on that, guys, don't miss today's session on how to search the internet effectively. You need to know all the basics in order to get content on the internet. So we have that session for you. Those who attended yesterday's session, well done. So today we have how to search the internet effectively at exactly 1. More to that, you have your other lesson at exactly 11. So don't miss all those sessions. Bye.